So this first thing is not in your notes. This is just to get you thinking about what we're learning. And I need to hire somebody to clean off my desk daily because I clean it up and then it just gets destroyed. Okay, so this is pretend. This is pretend. This is pretend. Quit raising your hands. I appreciate it, though.
So what's the fake money thing?
So the fake money is, you can either have...
She can't give you $100,000.
Is this a real?
Per day.
Per day.
I take Father's Day.
So, if you don't work a minimum 30 days, I'm not paying you anything. So, minimum 30 days, I'll give you $100,000 a day to keep my desk clean.
What is this money for?
Do you want us to write this down?
She
What?
said no.
What?
This is not the notes.
What 24 are you talking?
If you clean your desk for 30 days, you get $100,000
Per
per day.
day. On the 30th day.
Or be born with $1 million.
No, I'm good.
On the 30th day, what would you make?
30 times 100.
No. On the 30th day, what would you get paid for just that? It's $100,000 per day. So on the 30th day, you'd get $100,000. Now, different question. If you didn't spend a dime, how much would you have? If you didn't spend a dime, how much would you have at total from the 30 days?
100,000.
100,000. Which is what?
Just kidding, that's just stupid.
Total is 100.
Yeah, 3 million, or billion or something like that.
Okay.
She's saying if you didn't touch that money that you earned in those 30 days, then that's how much money you have.
You have
But on the
3
last day of the
million.
day,
Yeah, these are two separate questions here. On the 30, every single day, you get 100 grand.
Okay, what's choice B?
What, is choice A not good enough for you? Fine. I'll offer you choice B then. Choice B is day 1. You get a penny.
What?
Day 2.
That's even more confusing.
you get a cent for cleaning your desk?
Dude, that's
I've heard of this kind of thing before. I've what I've heard this kind of thing before.
Okay. We're going to double the amount
Oh, each day.
Yeah.
each day.
I think choice B would be good.
Choice B is the best one.
Why?
Because
How much would you get on the 30th
over
day?
time, you're doubling it by 2, which gives you more.
Okay.
How much would you get on the 30th day?
Let me pull out a calculator.
130 for 0.04 times 2 is 0.12. No, 0.8, 0.08. Oh, you're adding 2.
No, we're not adding 2. Wait, let me do another one so he doesn't get confused. Day 4, you would get 8 cents.
Oh, you just multiply by
Yes. Day 5, you would get 16 cents. So 5 days of solid work, how much would you have total?
0.16 cents.
No.
Total.
You gotta times that by
Oh,
2.
I think together.
I don't know. It would be 31 cents. After 5 days solid work, you'd have 31 cents saved up if you didn't spend it.
You can't even buy a piece of milk.
Yeah. So you
Hey, but you can get a,
so you still want choice B.
Snack Shack.
So you still want choice B.
Oh, wow.
You think there's a trick. That's what it is.
Does it cap off at?
There is, because once you start getting to whole numbers, then it starts getting bigger.
Yeah, but dude, by the time you get to 30 days, it's like $50.
At what day,
Certain day,
Preston, at what day am I actually going to get to whole numbers?
I'm saying day,
Well, these are multiples of 2.
yeah,
We just did a chapter over,
day 13, day 14.
well, what's 16 times 2? 6 would be 32 cents. 7 would be 64 cents. 8 would be $1.28. There you go. You made it over $1 on the 8th
Hey
day.
guys, you saw about all these other days left. You want to times by 2.
Times by 2.
Dude, that's
Yes.
not gonna beat
9 is going to be 2.56.
It's really not going to to be 3 million.
Okay, here is what you would get on the 30th day. You ready?
Yeah.
Look, watch it be over 30 million.
It's
3 million. You know what? I take choice B.
Yeah. Who wants to go against me now?
This is the amount on the 30th day. That is not the sum of all 30 days.
So you get to double that too?
No, this is the last day. So, like, the previous day would be that divided by 2, which would be... Oops. I just messed up something on my calculator. Like, the 29th day would be 268,354.56. So, like, just the 29th and the 30th day alone, over 7 million.
7.
Total, when you add them together. Like, if you didn't spend a penny, you just kept it in your piggy bank. Right?
That's too much money.
This stuff that we're doing today is called exponential. It grows really, really big, fast. I mean, it starts out slow, but then it grows big, fast. The smarter way would be to go with choice B. Try that on one of your parents. See if they'll give in, be like, hey, Mom.
That's too much work to write.
You don't have to write it. Just tell them what you're
And
doing.
then they're going to be like, let me get a piece of paper.
Just go back to the
Problem with that being able to that's stupid. They already know about this.
Yes, if they're smart, they will figure it out.
What if your parents
This is called exponentially growing. This is called exponential growth. Have you ever heard the word exponential used as an adjective?
I work in a financial
Okay. All right, I got a different situation for you. This one's a little bit more personal.
This one's going to be...
What do I get? Choice C for Christmas.
There's no choice C. So my daughter's birthday just happened. Yep. I made her cake.
Is she 9?
She's 8.
I was 4.
So I made her a cake, but I didn't hear what you said. I'll have to rewatch the video and listen. Can we move on?
I'm not, okay.
Can we move on? Can we move on?
Yeah, I'm still.
So I made a cake. Unfortunately, I occasionally I eat my feelings, and I really like cake. Well, I didn't eat all of it because I felt bad, so I just ate half of it. I just ate half of it. I really like cake.
I don't like it.
It was good cake.
But you said you don't.
Oh, I really like cake. Okay. After eating half the cake the next day, I felt like bad about myself because I ate half the cake. And because I eat my feelings, I was like, I got to eat another half of the cake. I felt bad. I ate the first half, so then I just ate half of what was left.
Did you get a piece of the cake?
This is before her birthday.
Now there's only 25% of the cake.
It was before her.
Yeah. So then, at this point, I was like, well, I'm going to have to make another cake anyway.
Her birthday cake?
Well, I mean, I already ate all this, so I was going to have to make another cake, so I just ate another half of what was left over. And then the next day, I ate half of what was left over.
What were you feeling?
I was feeling this cake.
I don't think this is a true story.
No, just like the first one was not true. Okay, then I ate half of that. Then I ate half of that. Then I ate half of that. Will I ever have eaten all the cake?
We're down.
We're done. Eventually you get a copy.
We're down to
So I ate half the cake. Then I ate a fourth. And then half of that would be the 8th.
16.
And half of that would be a 16th.
You're never going to finish it.
I'm never going to finish it.
There's going to be crumbs on the floor and stuff.
Yeah, well, okay, so So when we talk about in reality, first of all, this didn't happen.
So you didn't eat the whole cake?
I was working.
She ate the whole cake.
Yeah, I actually thought you did too.
I wish, man. Oh, I love cake. But in reality, no, this did not happen. And in reality, there's no way that I could keep eating half and half and half and half because the crumbs would be too tiny. But when we talk about numbers, I could half this infinitely. Infinitely. Am I saying that right? I could keep halving it forever and ever and ever. There will always be some left. Have you all ever heard of like carbon dating, where they find bones in the ground and then they...
Yes, and they were like mating back then.
No, they find out that these
And they can see how old the bones are by looking at how much carbon is left.
Everybody has carbon.
Yes. And we know what's called half-life. We know how long it takes for half of the carbon to disappear. And so they see how much carbon is left and they can figure out how old the bones are. Or maybe you've heard of half-life, where bacteria is, you guys have bacteria in you and you're taking medicine to get over something, and every so many days half of the bacteria are left and then half of that. This is all called exponential decay. This is all called exponential decay. Today we are talking about exponential growth and exponential decay. All of these have to do with exponents, which we just spent a whole chapter studying. Okay? Today, now we can go to our notes. Today, I'm going to kind of go through some of this a little quickly because I've explained a lot of it that you need to know, and I'm not going to read word for word this to you. In yours, it's in it's like highlighted. You can see, where is mine? There it is. It's highlighted. You can see the important parts. Exponential function is in the form of y equals a times b to the x. Oops, this went away, sorry. It's in the form of y equals a times b to the x. This b to the x part is the most simplest type of exponential function, which they wrote right here. Y equals b to the x. This is what we're going to start out looking at today. We're not going to have something with an a till block day. So we're going to just have y equals b to the x. Now, I've already told you about growth and I've already told you about decay. There's a way that you can look at this equation and tell if it's growth or tell if it's decay without even knowing what it has to do with. Like, you guys knew when I was adding money each time, when you were doubling it, it was getting bigger. When I was eating half of the cake, it was getting smaller. So that's exponential growth versus exponential decay. But knowing the equation, you can just like figure it out even not knowing what that equation represents. Question. Okay. Here is a picture of what all exponential growths will look like. Generally, they will start out really, really small, and then they're going to shoot up, left to right. Yeah, this is stuff that's used in real life. Exponential things are used in real life. Population growth, Austin, population growth. If two people have, right, if two people have 4 kids, and then those kids make 4 kids, you know, like exponentially getting bigger. That's what happened to population. What you need to know about is you need to know 3 major things. Exponential growth goes up from left to right. Both exponential growth have something called an asymptote. Asymptote. Until we have transformations, which we're not going to have transformations today, until we have transformations, the asymptote is y equals 0. On the graph, the asymptote is right here, y equals 0. And what an asymptote is, it's a line at which this graph is getting closer and closer and closer and closer to,
But it's not touching.
but it's not touching it.
When will it
In our class next, in the next level, it could.
So,
Josh?
So for now, we write down y equals 0 for every time.
For today, yes. What could possibly make this asymptote go somewhere else would be if we had a translate up or translate down, but today we're not going to do that. So we know that there's an asymptote. We know that it grows. And then there's one more thing, and it's written right here, but I'm just going to write it off to the side. The B value, if it is greater than 1, that makes it growth. So when I was doubling the pennies each time, it was getting bigger because we were multiplying when I was doubling those pennies. So anytime the B value is greater than 1, it will be growth. Now there is a picture of decay. That is the next thing we look at. Here's a picture. It falls. There is an asymptote at y equals 0. I like making you guys guess your immature, but you know.
I don't even understand
Asymptote. Okay. All right. So the asymptote is y equals 0. Again, we haven't done any transformations, so that's for now. It falls from left to right. You can tell the graph, it's written right here, you can tell the graph is going to be decay if the B value is somewhere between 0 and 1. If the B value is between 0 and 1, this is going to be decay. It talks about more things, but I'm going to hit everything that it talks about by doing examples. So we're going to do examples now. Yes?
My computer just
that sucks.
well, I just don't know. It just stopped writing it. So I had to restart.
You have to press the refresh button. Your page is still loading.
Okay. So she's going to figure that out. I'm going to give you a task. I want you to go through these examples, and we're going to determine if it's exponential growth or decay by looking at the equation.
That's growth.
What?
Because it's greater than 1.
Because what is greater than 1?
The B is greater than 1. B is greater than 1.
You should be.
So the exponential, it is exponential growth because that 2 is greater than 1. The 2 is the B value. It has the exponent on it. It is the base. Can we think of B being the base for the exponent? Okay, I want you to go through all of these examples and just say if it's growth or decay. I don't want you to do anything else.
Okay.
Take a moment. Growth or decay? I'll fill mine out. But I'm not putting them up there.
Why won't you let me go?
Yeah, you have your questions. We are answering. We did the first one together. We should do her.
You guys, we are answering growth or decay. The first two people I checked had did not have it done?
I have mine.
I didn't check. The first 3 people I checked did not have them done.
And read.
You would be the pastor of anything.
4 people I've checked in a row. Thank you for having it done. Did not have it done. You cheated. 5 people did not have it done. I did them all, and you didn't have any of them.
I still be surprising. I did not.
I wonder why I'm not doing well in algebra 2. No, it's if you don't do the notes, you're gonna learn. It's not like this stuff is stuff you
Do you want to see mine?
are born knowing.
Here you go. I'm coming.
Not like you are born knowing this stuff. You only learn by.
How do you think of the geniuses that have like?
They do not know what exponential decay is.
They're geniuses.
You are not. That's because they study. Or they catch on with anybody who's. Yeah. But you can't go to college if you don't know how to do it.
Bro, he's already on the homework. Oh my gosh.
I'm gonna have one more key point for each of you that I'm gonna do one more.
He just talked about sometimes like
Is that how you found? Or not divided by like you say this?
I haven't done it before, but I got it.
So you're definitely doing it correctly.
But
I'm gonna have it.
is it like what?
All right, we are moving on. So now, we're going to talk about what I want to see. This is basically what your assignment looks like as well. What I want to see from you. And we are not using our calculator. Oh my gosh, we will use our calculator in here. But we are not using our calculator to plug in a 1.
Okay, that makes sense.
Because if you do it with your calculator every time, you'll never be able to do 2 to the first power by yourself.
Wouldn't it just be 2?
Yeah. All right. So we know that there's exponential growth. So asymptotes we've talked about. What should the asymptote be? 0.
Is that for everything?
It is 0 until we do transformations, and we haven't done transformations. So today, yes. Forever, no. So I'm going to draw in that y equals 0 asymptote. I'm making it thicker so you can actually tell I drew it in. Okay. Now the next thing we're doing is we're going to do key points. Before I fill out key points, I'll tell you how I got my key points by making a table. Well, these tables are easy. If you were going to make a table and you wanted to plug in the easiest number possible,
1, 2, 0, 1, 5.
what number would you plug in? Okay, 1 is one of them I know you would plug in. So let's plug in 1.
0.
It's too late. She already put 1 down.
I left a space. So if I plug in 1, I get 2 to the first, that is 2. So 0 is another easy one to plug in. 2 to the 0. Anything to the 0 power is not 0. It's 1. That was from chapter 5. Anything to the 0 power is 1. Now there is another key point that I like to do. I like to plug in -1. Now that might not be your favorite to plug in, but I like to plug in -1. If you plug in -1, you get 2 to the negative first power. And what does the negative exponent do? It reciprocates. What?
Because somebody invented it.
So
Just think about
you're
us
pretty
multiplying
quiet,
three
and I
times
can
zero.
hear part of what you're saying.
If 0 is the exponent, how is it 1?
Because everything is
Yeah, anything to the 0 power is 1. Now, I can show you why, not while I'm doing this video. Okay? But I can show you why. I can answer your question.
Oh, it makes sense.
Okay, so let me graph the ones I have so far. 0, 1, 1, 2, negative 1/2. Does it look like it's growing from left to right?
Yeah.
Now, how many of these have you graphed in your lifetime?
3.
None.
Oh.
Not a lot. Not a lot. So until you understand what this graph looks like, it may be helpful to plug in some more numbers.
Let's do 2.
Plug in 2. So, okay, what's 2 squared?
4.
Okay. So 2 is 4. What about 3? 8. And if I plug in 4, I'm off the graph, so I'm not going to plug in 4. You see it is not a line. It is a curve. What if I plugged in negative 2? I have 2 to the negative 2nd power. Sure, I was a scammer.
What goes your doctor?
From reciprocates, and we square it, so 1/4.
Oh, that's how that works?
So negative 2 would be like 1/4. So once I have more points, I can tell that this graph is growing exponentially, and then to the left it's getting closer and closer and closer to the asymptote, but it's not going to go below. It's not going to equal 0. There's nothing I can plug into this exponent gives 0 as it. If you are doing other things right now on your computer, stop. But also, you don't need to do a computer. You can do this on paper. The key points that I would look for on your assignment, because there's a blank that says key points, would be negative 1, 0, 1, 1, 2. And that's like basically minimum points that you would need. But until you understand the way the graph looks, you might need some more. And you saw how easy it was to find more points.
So we just need incremental 3.
Yep. You need to plug in negative 1, 0, and 1. Those are going to be the key points. That was for parabolas. 5 of them might not always fit on the graph.
Also, it's like it goes off the graph.
Yeah, so like you might have a graph that like starts out all the way up here after 1.
What?
Well, if the b value is 8, then it would be here for your first point. Okay, domain and range. So domain is all the x values. We could look left to right, or you can think of what am I allowed to plug in x?
X is greater than or equal to 0?
X goes left or right. And this arrow
X is greater than or equal to negative 1.
is never going to stop going this way. It is all real numbers. You're allowed to plug in anything into this exponent.
Range is not all.
The range is not all real numbers. So the range goes down to up.
Y is greater than
Is it equal to 0?
Y is greater than 0.
So this time it's just greater than 0.
Wouldn't it be 1 though?
No.
Nope, because I had a half and I had a fourth.
It just won't go into the
It just won't touch the asymptote, right? And that's like what your homework assignment's like.
That's it.
Yep. Let's look at
So do we have to do more?
the second one, decay. Did you get decay?
Yeah.
Okay, we're not going to do that one. The third one was growth. Did you get growth?
Yeah.
Okay. The fourth one was decay. Did you get decay?
Yeah.
Let's do that one.
Whoa.
How was that decay if it's 2 halves, which is
That's 2/3.
2 divided by 3?
2 divided by 3 is 0.666666667.
Okay, we get it. Really stop.
So the answer is 2/3 is in between 0 and 1.
That's the answer.
So it's decay. No, that's why it's decay. She asked why it's decay.
Yeah, I understand that.
All right. What is my asymptote?
Y is equal to
Okay. And it's going to be y equals 0 until we have transformations. We're not going to have transformations today. Key points. So before I know how to do my key points, let me just make a table. What should I plug in?
0.
-1, 0, 1, and maybe more. So if I plug in -1, I get 2/3 to the -1 power. What do I do when I have -1 power? Josh?
Flip it.
We reciprocate it. So I'm going to get 3/2 or 1.5. So at -1, 1.5. If I plug in 0, 2/3 to the 0, 1. You're right. That's why it's one of our key points.
So is it always going to start at 0, 1?
Unless we have transformations, yes. And then if I plug in 1, I get 2/3. So there's always also going to be 1, the b value. 1, the b value, the base, until we have transformations, right, for now. All right, is that enough for you to make a nice accurate graph?
No.
Okay, so let's
Do more negatives.
do more negatives. Yeah, because my positives, I know those are going to get closer and closer. Now, I did this in my last class, and like, you guys are just going to guess numbers and try them. I don't suggest we try every single integer. Maybe like skip around. Let's try -2. That's an easy one. 2/3 to the -2. The negative itself tells me to do what? The reciprocal is the negative, and then we also have to square it. So we do 3 and 3. We do 2 times 2, so we get 9/4 when you flip it and square it, which is 4 1/4. Oh, 2 1/4. Sorry. Right there. So like it's kind of still going slow. How about 1, 2, 3? Let's do 4. Yeah, let's do -4. I did not do -4 in the other class, so I don't know what the answer is. So part, and then I also have to do like 3 to the 4th and 2 to the 4th. So I'm going to have 81 over 6. Just calculate that real fast. And I'm going to. And it is just, it's like, oh gosh. It's like 5 1/16, so it's just over 5. I'll just write 5 1/16. Oh yeah, I could have done that without a calculator. 16 goes into 80 5 times. So 5 1/16, 1, 2, 3, just over 5. So now you can see there's like more of a curve to it. Probably could have fit 6 in there too. And until you've done a few of these and seen what they look like, you may need more points. But our key points are just 1 3/2, 0, 1, 1 2/3. Those are going to be our key points. Our domain. How far to the left, how far to the right? How far to the left? Is there anything that's going to stop this from going this way? Okay, so it's all real numbers for domain.
And this is y is greater than.
Y is it equal to 0?
When is it equal?
I don't know, that's because you're used to doing it. So it's an easy mistake to make. All of these are the same, just some of them go up, some of them go down. But they're all the same. So your assignment, I don't feel like we need to do another one. Your assignment is a worksheet, and I'm going to pass that out.